we're asked to find the equation of the tangent line to this curve at this point. So how do you find the tangent line? Well, to find any equation of a line, right, you need the slope and you need a point. We've been given the point, but we have to first find the slope. And the slope is the derivative. So I'm going to take the derivative of this equation here. But you can see here that this is going to be a product rule when I take it. So I'm going to start there. Y prime equals, I've got the first times the derivative of the second minus 1, so that's just a 1, and then the inside is just 1. Plus, now I'm going to do the second times the derivative of, so I'm going to bring down that 5, minus 2, 4, and then I have another 1. I'm going to do a little bit of cleanup, but I'm not going to do a ton. I'm going to explain why here in a minute. So I'm just going to kind of, this is 2x minus 2 to the 5th, x plus 1, plus 5x plus 1 squared, x minus 2 to the 4th. Now, at this point, I could do a bunch of factoring, but I don't really need to because I want the slope at this exact point, right? So what I'm going to do is I'm going to put in the x value, and I'm going to get an actual number. So I need a number here. This is the equation for this is the slope for anywhere on this graph, but this is a huge graph. It's a polynomial. It's going to do all kinds of crazy stuff. The slope is changing. This is the formula to find the slope at any specific point. This is our specific point. So I'm going to put a 2 in here. So this is going to become a 1. This is going to become a 4. Well, not a 2, a 3. So, because that's 3 minus 2. And then this here is 5. This is going to be 4 squared. And then this is going to be 1 to the 4th. So now I'm going to clean this up. So this is 1, so this is 8. And this here is 16 times 5. 16 times 5 is 80, so this is 88. So my slope is 88. So I've accomplished my first step. I found my slope. Now I need to write the equation of the line. We're going to use point slope, y minus y1 equals mx minus x1. And so I'm going to use that same point, the 3, 16. So y minus 16 equals 88, x minus 3. Now I think it will actually accept it here. I don't like this because I then couldn't easily graph it. I'm going to rewrite it into slope-intercept. So I have y minus 16 equals 88x minus, let me go pull up a calculator somewhere. I have it up. What do I got to do? I got to do 88 times 3. So this is 264. And then I'm going to add 16. So y equals 88x. So I'm really subtracting. Minus 248. So this is my tangent line at the point 316 of that polynomial graph. And if I wanted a different point, I would use the same derivative, but I would just put in that different point so I can use it for anywhere we want. So you can see here that the steps for finding the equation of a line haven't changed. You need the slope and you need a point. How you get that slope has changed in that we're now taking derivatives and we're getting more complicated in our derivatives, but it doesn't matter. We still take them. Depending on what you're doing with an equation, with a derivative, really tells you how much work you're going to do. I'm not going to put a bunch of work in cleaning it up, making it all pretty if I know I'm just throwing a number in there and crunching it out. So it's up to you. Obviously, you could have chose to do that thing. Well, I don't want to worry about having, that many numbers. I'm likely to mess it up. That's completely up to you. So hopefully this helps you. Refresh those. We really want to make sure we know how to find a tangent line. That's a skill you want really good and solid.